ADCS, analog to digital conversion clock select bit. I told that ADC is also a circuitry, a digital circuitry that need a clock to operate. From where we have to select that clock? We have to select that need a clock. No, we have to supply a clock to it or not. Come on. See, every peripheral in a microcontroller require to clock to operate. Right? Most of the cases we won't use operating clock, microcontroller operating clock as a peripheral clock, because usually peripherals will be slower than the microcontroller. Right. So for that, how to use the operating clocks? Whether are we going to use the operating clock as such, or how are we going to divide that clock, reduce the frequency of the clock to further? That we are defining using ADCCS, meaning that ADC conversion clock select bit. ADC conversion clock select bit 2. So these are 2 bits actually. ADC FM, but here one is missing. I think this is part of AD con not. It is a part of another register. Totally, we have 2 bits, right? If those 2 bits are 0, 0, if you don't touch those bits at all, you will get total operating frequency of your microcontroller divided by 2. If I am operating my clock in my microcontroller 20 megahertz, means what is operating frequency of ADC? It is 10 megahertz. Understood? Come on.
Yes, sir.
Right. Actually, here there are totally 3 bits. It is ADC con is ADC clock conversion clock select bit. No, it is 3 bit. 2 bits are in ADC AD con not, only 1 bit is here. So here is the combination. 0 0 0 means F oscillator divided by 2. 0 0 1 means F oscillator divided by 8. 0 1 0 means F oscillator divided by 32. 0 1 1 means FRC. FRC means clock derived from internal ADC RC oscillator. I think there is an internal RC oscillator they have. From that they are getting the clock. If we set 100, F oscillator divided by 4. 101, F oscillator divided by 16. 110, F oscillator divided by 64. That means 20 megahertz divided by 64. That is your operating frequency of the this one. Like if you make all things to 1, FRC clock derived from the internal ADC RC oscillator. Even if you set all 3 bits to 1, the meaning is same. Understood? This is like what is your operating clock of ADC? How we are going to derive that clock? That is derived based on these 3 bits. ADC, AD con 1 bit, AD con not bit. AD con not we have 2 bits. AD con 1 we have 1 bit. AD con not is another register, separate register, 8-bit register. AD con 1 is this register that we are talking about. In this only the MSB bit is there. If you look at this AD con not right now, AD con not, here we have. So you should not, you cannot directly use only these 2 bits alone. You have to combine these 3 bits together to see the greater picture. Understood?
Yes, sir. Sir, this first way we give the 5 volt to one pin, and we got the like equivalent analog digital
Word.
yes, words. These are ADCON register only, no, sir.
Super. Thank you. This ADCON 1 ADCON not are control register. They are not nothing to do with result register. This is like here I have a separate register AD con not AD con 1. Right now,
Yes.
these are 8-bit in size. 8-bit in size. Your ADC converted 5-volt result will not be stored in this register. They are control register. The result are stored in AD result H, AD result L. Those are another
Okay.
independent register. Your 5-volt result, 5 digital word that you are getting after the conversion of ADC, no, that will come and sit here, not here. These are just like a control register. How this ADC should operate.
Yes,
Got
sir.
it now. So this
Got it.
is directly given to the ADC that we have inside this particular microcontroller. Understood?
Yes, sir. Understood.
So how this operate, how speed it should do the conversion. So that is defined by these two register. Actually, from those two register, they use 3 bits. 2 bits from AD con 1, not 1 bit from AD con 1. Understood?
Yes.
And then AD port configuration control bits. AD port configuration control bit. So how many pins? Totally, it is an 8 channel. 8 inputs can be, 8 physical input can be digitized. 8 analog inputs can be digitized using this particular microcontroller because it has 8 channels. As it has 8 channels, it doesn't mean we have 8 analog to digital converter. Don't think like that. It is a single analog digital converter. It receives input from 8 different pin. So when we convert them, we have to convert them one by one by selecting which channel we are going to digitize first, which channel we are going to digitize next. There will be a configuration register. We will see that very in a while, right? So here they are saying whether those pins are an analog pins or digital pin. I told no, there will be a configuration because these pins are multiplexed. The port A pins are multiplexed. They can be used as an analog input pin as well as digital input IO pin. So to configure that only, they use PCFG3 to PCFG0, totally 4 bits. When you set those 4 bits to 0, right, AN0 to AN7, all are analog, meaning that you use the pins dedicated for ADC as an analog input pin. Got it? Right. All pins are that one. So the VDD, see the ADC require for 0 what voltage that it has to use. For maximum value, if I make all 10 bits to 1, see it is a 10-bit ADC, no? When we make all 10 bits 1, what we will get? 1 1 and then 1 1 1 and then 1 1 1. So when I digitize this, I will get 3F F. Correct? Yeah, yes or no? Right. 3FF is the maximum value. And then when I make all 10 bits to 0, I get 0 as the result. Yes or no?
Yes, sir.
So this is maximum, this is minimum. So when I have to get 3FF, if I supply 5 voltage, I have to get 3FF because that is the maximum voltage. If I supply 0 volt, I have to get 0 as the result. If you set these PCF register all 4 bit to 0, it will consider VDD is like voltage supplies to the microcontroller. High voltage supplies to the microcontroller. Usually we will supply 5 volt. VSS means the ground voltage supplied to the microcontroller. Usually we supply 0. Understood? So when you supply 5 volt, they will convert that into 3FF. When you supply 0, they will convert that into 0. But here, when you set only the first bit of this PCFG, meaning when the value is 0001, right? Here, you have to supply the voltage to be used to make voltage to be used to represent the maximum value. Meaning, I have to supply a, for example, let us say I supply 4 volt in V reference, then that is my maximum. My minimum is 0. So when I supply 4 voltage in that particular pin, they convert that into 3FF because I define the maximum voltage.
Yes, sir.
When I supply 0, they will represent as 0. So if the value is in between 0 and 4 volt, I will get the value in between 0 to 3FF. But here it takes by itself. The supplied voltage to microcontroller is considered as V reference plus. Right? That means the maximum voltage to be considered. 0 voltage is considered as VSS. So like that. So here only I am supplying the maximum voltage. When I said that one here, least these 3 pins, AD5, AD6, AD7 are digital. I am not using all pins as, all 8 pins as, I am not using all 8 channels. Among those 8 channels, 3 channels are used for digital. Remaining, this is 4 and 5. 5 channels are used for analog. Then when I set that value to 0011, 3 pins are used for digital, 1 is analog. Here I define a maximum voltage 2. Understood? Right. And then remaining things are analog. So when we set that to 0100, 4 pins are 4 analog channels that we have are used for digital I/O and only 3 are used for analog. Depends on your project requirement. You can choose which pin you want to use as analog, which pin you want to use as digital. Understood? Come on.
Yes, sir.
When I make these all bits of this PFG not to PCFG to 1, I make all of them, I believe nearly except 1, we make all our digital I/O. Right? Like that we do.
V reference, can you
V
repeat once?
reference. Okay. The voltage used to make or represent digital 1. See, when I give 5 volt, they will make all these 3 bits, 10 bits to 1. When I give 0 volt, they will make all 10 bits to 0. If I supply a voltage in between 5 volt and 0 volt, according to that, they will have the value, digital value. When I supply V reference by myself, this is what the maximum voltage to be used by the ADC means. They will give 3FF when I supply the voltage that you defined. That means what? So voltage that you define. Voltage that I define means where I have to communicate that voltage that I define to the microcontroller. No, that is what they are trying to say. Reference voltage. From which pin they will get that voltage. Here A and 3 is used as a reference voltage. Okay, let me explain the thing here. See, I have not defined any V reference voltage in this first case right now. In this first case, I am not referring any V reference
Means
voltage.
one of the pin it will take as V reference, right, sir? That is the meaning.
So here it takes our microcontroller operating voltage as V reference when we
Yes.
set all these bit to 0.
Yes, sir.
When we set this value 0001, AN3, not one of the pin, particularly that AN3 is used as a V reference.
Okay, we can provide the voltage we want.
We
Here.
want, yes. Understood.
Yes, sir.
Voltage to
V
be considered as a maximum. Actually,
VS,
it is just like a sort of calibration.
yes,
Any,
sir.
any other doubt?
VSS will be by default 0 only, right, sir?
Yeah, that is always 0, but it is sometimes you can even define V reference minus that we have now, which is meaning that you want to start not from 0, you want to start from certain voltage to be considered as 0. Meaning that, let me explain it here. Here, when we supply 0 only, we get 0 now.
Yes,
So you can set your V reference minus as some 2 volt means when you supply 2 volt, they will consider that as 0. That means we are offsetting. Instead of using 0 voltage, we are offsetting. When you set your, because you have to, we are supplying V reference minus no in A and 2. So when you supply like that, so they control the range. The value, when you supply 2 voltage, they will convert that as 0. When you supply 2.1, they may 2.1 or 3, then they will consider that as 1, something like that. So your entire voltage range will be input output. There are certain sensor that will output the voltage in between 2 volt to 4 volt. They won't output 0 volt. There are certain sensor, yes or no?
yes,
So in those cases, I have to consider that 2 as 0, 2 voltage as 0, and the maximum voltage as the maximum digital value right now.
yes,
So for that, they use this V reference minus.
yes,
Got it. So
yes,
that is why we have a V reference. If the sensor is producing from 0 to certain volt, we no need to bother about this V reference minus.
yes,
Understood?
yes. So
Okay.
we have three registers, right, sir? Now, like for port configuration, the PCFG, and uh,
These are
the
not
add
independent register. They are bits in this particular register. Which register? ADC CON1.
con one.
The CON1 totally 8 bits we have now. In
Ah,
that
yes,
first one, this MSB, 7th bit or like 8th bit in 8th bit is used for justification. And then the 7th bit is used for conversion clock selection.
okay,
Right now.
yes, yes,
Right. These 2 bits are unused. And then the 4 bits that we have, least 4 bits of that ADC CON1 is used for this purpose. Selecting which pin going to be an analog, which pin going to be digital, and what is my minimum reference voltage and what is my maximum reference voltage. For that they are using it. Understood?
yes, sir. Got it, got it. Clear. It's clear.